Hello students, welcome to Marine Engineering Tutorials. I am Atul Kumar Gupta and I am back with a new tutorial. We are currently studying marine boilers. This lecture describes about the development of Aalborg water tube boilers which are widely used as auxiliary boilers on motor vessels. First, we will discuss about the construction and operation of Aalborg AQ-3 water tube boiler, which was the original design. Next, we will examine the features of Aalborg AQ-9 water tube boiler, which was developed for moderate pressure used on conventional oil tankers. Finally, we will discuss about the construction and operation of Aalborg AQ-18 water tube boiler, which is most modern in the series of their development. Let us now go through each of these topics one by one in the following slides. Aalborg AQ-3 boiler. This boiler was developed by Alpha Level Aalborg, Denmark during the middle of the 20th century, which is a tank type auxiliary boiler with vertical layout used for low capacity and low pressure applications on motor ships. Boiler consists of a cylindrical shell with dish-shaped crown plate. The shell is covered by insulation to prevent heat loss. Similar to smoke tube boilers, a hemispherical furnace with slanting sides and a rounded crown is attached at the bottom of the drum, which is surrounded by water except the bottom. The bottom of the furnace has brickwork and refractory lining to contain the furnace heat. Burner is attached to the furnace through the burner tube connected between the boiler shell and the furnace site. Access to the furnace for maintenance and repair is provided through the burner tube. Dome-shaped furnace crown is self-supporting and avoids any stays. Two tube plates form the steam generating section to which generating tubes are attached which carry water through them. The generating tubes consist of plain and straight tubes which are in the ratio of 2:1. The straight tubes are arranged in the form of a ring as close as possible to the periphery of the tube plates to reduce stress concentration caused by steam and water pressure that tends to bulge them inward. Flat tube plates are additionally supported by stay bars to prevent their distortion due to external pressure exerted by steam and water. Although water can circulate in the boiler naturally due to convection currents caused by density differences, two large size internal downcomers are provided to achieve a higher circulation rate during maximum steaming condition. Space around the furnace forms water chamber and the water level is maintained above the top tube plates, ensuring that the tubes remain full of water to prevent their overheating. Steam is collected in the dome above the water level. The flue pipe connects the furnace to the elliptical smoke box, which uniformly distributes the flue gases around the large number of vertical generating tubes connected to the tube plates between the water chamber and the steam and water space. Flue gases, after exchanging their heat with the water, leave the boiler through the uptake. Two manholes are provided for internal inspection and repair of water chamber and steam space. Smoke side is provided with inspection cover for cleaning the tubes from outside. This boiler has an oil-welded construction and the shell plating thickness is below 20 mm. This boiler is available in various sizes ranging from 800 kg per hour to 12,500 kg per hour with working pressure of about 7.5 bar. When higher steam pressures are required, the furnace design is modified to water wall construction as described in the following slide. Aalborg AQ-9 side-fired boiler. This sketch shows a modern Aalborg water tube boiler with side-firing arrangement. It consists of a cylindrical steam drum and an annular water space with flat ends supported by stay bars. Both of these drums are equipped with manholes for internal inspection. A number of tubes are connected between the annular water space and the steam drum, which generates steam by utilizing the convective heat of the flue gases. The furnace is surrounded by row of closely pitched membrane wall tubes which are connected at their lower ends to the circular water header in the form of a ring and at their upper ends to the annular water space. The water wall tubes primarily utilize the radiant heat of the flame to generate steam. The bottom of the furnace is covered with fire bricks to prevent heat loss. The ring header, together with the fire bricks, are lined with refractory material. To achieve good circulation of water through the water wall tubes and to prevent their overheating, large bore downcomers tubes are provided between the steam drum and the ring header. Burner is attached to the side of the furnace. Burner hole is also used as an inspection opening for the furnace. Feed water is supplied in the steam drum and water level is maintained up to the normal water level. The flue gases then leave the furnace through the flue pipe located in the center of the annular water space. Baffle plates distribute the flue gases around the generating tubes in the smoke box. After exchanging their heat with the water circulating through the tubes, the flue gases exit the boiler through the uptake. Steam is separated and stored in cylindrical steam space above the water level. These boilers have a steam evaporation rate of 15,000 kg per hour or higher and can achieve steam pressure up to 16 bar, making them suitable for application on motor tankers. Aalborg AQ-18 roof-fired boiler. This sketch shows the Aalborg AQ-18 roof-fired boiler, which is very suitable for conventional oil tankers. This vertical tank-type boiler has two cylindrical drums with flat end plates held together by vertical solid stays. The steam and water drums are connected by the inner row of screen walls, two rows of generating tubes, and the outer membrane wall. The generating tube bank consists of vertical pin tubes which improve the heat transfer from the combustion gases to the water in the tube. For efficient water circulation, the two drums are also connected by a number of large diameter external downcomers. The screen wall surrounds the furnace and absorbs the radiant heat from the flame. The bottom tube plate is protected from the radiant heat of the flame by a base layer of insulating refractory covered by an upper layer of castable refractory. A roof-fired steam atomizing burner is located at the top of the steam drum with a passage for air and fuel supply through the drum. The roof firing arrangement requires a taller furnace for efficient combustion. The sectional view of the furnace illustrates the direction of flue gases passing through the generating tubes. The bottom of the furnace has an opening in the inner screen wall which helps distribute the flue gases around the two rows of generating tubes and exit from the top on the opposite side. Entry into the furnace can be made through the access door, which allows internal inspection of the screen wall and partial inspection of the generating tubes. The generating tubes can be cleaned by water washing through 8 external sockets provided for this purpose. A steam heating simmering coil is fitted in the water drum to maintain a suitable temperature in the boiler when the exhaust gas boiler is operating. This enables the auxiliary boiler to be brought into service quickly if the need arises. Feed water is supplied in the steam drum and a float level switch monitors the water level in the boiler and provides a low water level signal to cut out the burner. Steam is taken out from the outlet on top of the steam drum. Both steam and water drums are equipped with a manhole for internal inspection. The local gauge panel and all relevant boiler fittings are mounted at the top of the boiler. The control system enables fully automatic operation of the boiler and burner systems. The Aalborg AQ-3 boiler has an evaporation rate of 25,000 kg per hour, steam pressure of 16 bar, feed water temperature of 85 to 95 degrees centigrade, and atomizing steam pressure of 6 bar. This boiler can use heavy fuel oil up to 700 CST at 50 degrees Celsius. This completes our study on the development of Aalborg water tube boilers used on motor vessels as an auxiliary boiler. This book has been written by me and covers all the topics as per the Indian Maritime University syllabus. It explains key concepts using simple illustrations. The book also includes answers to all questions that have appeared in examination conducted by Indian Maritime University. It will help students prepare effectively for exams and also support them in working safely with ship boilers. I hope you enjoyed the lecture. Feel free to share your feedback in the comment section. If you found this tutorial helpful, consider sharing it with your friends. Subscribe to the channel to stay updated with upcoming tutorials. I'll be back soon with a new lecture. Thank you for watching till the end.